Chapter 6, Lesson 4, Part 1. In this lesson, we will study how to find the equation of the line. So what we have is a line and we want to reach its equation. There are two ways that we can use them to find the equation for any line. The first way is using the standard equation, ax plus by plus c equals 0. What are these symbols? A, B, C, they are real numbers. X and Y are making the ordered pair that represent any point on the line. There is something we needed when we solved this equation, saying that the slope of this line that has this equation equals negative A over B. Take care, A and B are the real numbers in the equation. This is the first part, the standard equation. The second part of the lesson thus saying that if we have 2 points, then we can reach the equation. So if we have 2 points means that we want x1, y1 and x2, y2. So using x1, y1 and x2, y2 remind us by the slope, which equals y2 minus y1 over x2 minus x1. This is the formula that we will use to find the equation for a line when we have 2 points, saying y minus y1 over x minus x1 equal y2 minus y1 over x2 minus x1. So if we replace this fraction all by m, this is going to be y minus y1 over x minus x1 equal m. So if we multiply x minus x1 by m, the equation is going to be y minus y1 equal m multiplied by x minus x1, and we know that m is the slope. Notice that here, when we find the value of y1 and x1, which are just any point on the line, and m we have it, the slope, so only x and y are unknown. So this is going to reach us again to the standard equation. So if we have 2 points, we use this formula. If we don't have 2 points, we go to this formula and we find the slope from using negative a over b. Now in example 9, we want to find the equation of the line passing through 2 given points. So if we have 2 given points, we will directly use this formula. Y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. So which one of them must be x1, y1? Thus we can determine it. So this is x1, y1 and this is x2, y2. Then we will fill y minus y1, which is negative 3. This is y plus 3 over x minus 2 equal 5 minus negative 3 and 4 minus 2. Now this is 8 and this is 2, and then y plus 3 over x minus 2 equal 4 over 1. Using proportion properties, we will multiply, then y plus 3 equal 4x minus 8. Transfer the terms, it's going to be 4x. We can transfer this side here to keep 4x positive, so this is going to be 4x minus y minus 11 equals 0, and this is the equation of the line. Here is the graph. This is the point 4,5, and here is the point 2, negative 3, and this is the line. Now in example 10, find the equation of the line passing through other 2 given points, but we want to reach something else. Is saying, and does the point 3, 4 belong to it, belong to that line? So first of all, we will find the equation using the formula of 2 points, apply the values of x and y for both sides, and then this is going to be 3 and here is negative 7, multiply using proportion properties. So the equation is 2x plus 7y minus 21 equals 0. Now we want to check, is the point 3, 4 belong to this line or not? So here is the equation. Instead of y, we substitute for instead of x we substitute 3, and here is the substitution. The answer is going to be 13, but the equation saying that this equals 0 and 13 is not 0. That's why 3, 4 does not belong to the line, and here is the graph, and it's clear where is 3, 4. Now in example 11, find the equation of the line passing through the point 1, negative 3, and with a slope 1 over 2. Here we just have 1 point, but we have the slope. So if you remember, if the value here x minus x1 will be under y minus y1, it equals to the formula of 2 points. But in the truth, since we have the slope, so directly 1 point, x and y, with the slope, I use this formula directly. So I can say y minus negative 3 equal 1 over 2 multiplied by x minus 1. Of course, this is going to be y plus 3 multiplied by 2, 2y plus 6, and here x minus 1. Terms will be transferred to one side, and then x minus 2y minus 7 equals 0, and here is the equation and the graph. In number 12, example 12, we want to find the equation of the line passing through a point A and the midpoint of the line that ends are B and C. So if I have the ends of the segment BC, I will find its midpoint. Say that it is D. So using the midpoint formula will give me the point D. That this is the point D, which is represented by 1, 1. Here it is. So from this point to this point 1, negative 3, which is A, I'm going to find the equation of the line passing through A and the midpoint of BC. So this is A and this is the midpoint. Now I have 2 points. I go directly to the formula of 2 points and apply the values of D, and this is the values of A for x, y, and then I will simplify. This is going to be 0. 1 minus 1 is 0. Negative 3 minus 1 is negative 4. This is y minus 1 and x minus 1. Take care that this is 0 multiplied by y minus 1. And negative 4 multiplied by x minus 1. Here are they. This side all is going to be 0. And 4 negative will be entered to the parentheses. This is negative 4x plus 4. Transfer 4, it's going to be negative 4. Divide both sides by negative 4, then x equals 1. This is the equation. And if you remember, we talked about this type of equations. This is a vertical line parallel to y-axis. So wherever you put a point, the value of x is constant. It is 1. Just check this value x here 1, and this is here 1. So that's why we don't need to write all details directly. We say this is an equation of a line which is x equal 1. On example 13, find the equation of the line passing through the origin and negative 3, 5. The origin is the point 0, 0. Here is 0, 0. So I have 2 points. So directly I go to my relation of y minus y1 over x minus x1 equal y2 minus y1 over x2 minus x1. This is 5 and this is negative 3. Proportion, since y minus 0 is y, x minus 0 is x. So negative 3y equals 5x. Transfer negative 3y here. 5x plus 3y equals 0. This is the equation. And just one little note, this is compared by the standard form of the equation. This is A and this is B, and C equals 0. Go to example 14. Find the slope and y coordinate of the line. That's equation is this one. Now I have the equation in the standard form, so I directly say to find the slope I use m equal negative a over b. Thus negative a, this is a, so it is negative 3 over b is negative 4. So this is the slope. Now if I have the slope, how can I use it to find the y coordinate? I know that many points are on the line, so how can we find the y coordinate? In such case, directly I say to find y, we assume that x equals 0. So what is the value of y when x is 0? This is the way of solving to find y coordinate. So 3 multiplied by x minus 4y minus 12 equals 0, thus x equals 0. This is going to be, this term all is 0, so this is negative 4y equal now minus 12, equals 0. Transfer negative 12, it's going to be positive, divide by negative 4, so the value of y is negative 3. Now on example 15, we have find the equation of the line that makes angle 150 with the positive x-axis and passes through this point. So the sentence line makes angle 150 with the positive x-axis means that the line here and this angle from positive x-axis to the line is 150. So I will need this angle to work on it. Since I have just 1 point, so what will the angle help me? That's related to the previous lesson. If you remember in the notes in the beginning of the lesson, I told you that the slope of the line equals to tan the angle that is made with the line and the positive x-axis. So I will need tan 150. Now tan 150 is tan 180 minus 30. This is 150. Thus equal negative tan 30 by a relation. This is the relation and it is found on page 71 in the book, where tan 30 is 1 over square root of 3, and since there is a negative, here is the negative. This is the solution using a formula, but if we look at this graph that I made it for you, angle 30, how did I know that this is 30? 150, to reach 180, I need 30. So the reflexive property saying that this is 30. The cosine and sine for 30 is the same as cosine and sine for 150, except the signs. Since here this is negative, the cosine, and the sine is positive, while here all of them are positive in the first quadrant. Now, I can directly say the tan is sine over cosine. So I directly remember that sine 30 is 1 over 2, cosine 30 square root 3 over 2, and then I can multiply to reach the tan, or divide to reach the tan. Or I can use this formula, no problem, this case, this way of solving, or what I told you about. In all cases, y minus y1 equal m multiplied by x minus x1. Thus 4 and 1 came from the given point. So y plus 4 equal, this is the slope, multiplied by x minus 1. Square root of 3 is going to be multiplied by y plus 4 equal negative 1 will be multiplied by x minus 1, it will be 1 minus x. Now transfer all the terms to one side. This is going to be x plus square root 3y plus, I put them in parentheses to represent c, because you know it is ax plus by plus c equals 0. So this is the equation of the line. On example 16, find the equation of the line passes through also 1 point and perpendicular to line's equation, this one. So I will do the same thing. I will go to the line, use this equation, find the slope using negative a over b. This is the slope. Now this is for the line given. The perpendicular one is negative 1 multiplied by the opposite, 3 over 2. So this is the slope of the required line, which is perpendicular. Now the equation can be found using this formula. I have a point, I have the slope, apply them here, and then 2y minus 2 plus 3x plus 6 equals 0. 6 and negative 2 is going to be positive 4, and this is the equation of the required line.